Alright, so this video might be helpful for you if you are struggling with the angles part of the test. Part 2 of our test, or its retake, deals with angle relationships, which really starts with the vocabulary. So there's 4 words that we really need to know about right now: adjacent, vertical, complementary, and supplementary. So, adjacent and vertical both refer to where the angles are in relationship to one another. Adjacent tells you nothing about the angle measurements. This angle and this angle are adjacent to each other because they're just right next to each other. They have a side that's in common, that side, and there's no overlap between them. Actually, let's use 2 different colors. This red angle here and this green angle here. They share this overlapping one side, this side AX, but they don't have any part of their angles that are overlapping. I'm going to call this angle GXA, and this one is AXB. Those 2 angles are adjacent to each other. I don't know anything about the angle measurement. I don't know how many degrees they are. I just know that they're right next to each other. That's all adjacent is saying. They are next to each other. Vertical and adjacent are it's never going to be both of those 2 things at the same time, because vertical really means that they're across from each other. So let's start out with this GXA down here. Angle GXA is that one. If I'm thinking about the angle that's vertical to that, I really want to think about like extending these lines. This little wedge here, that wedge in there is this angle GXA. If I extend those lines, that one and that one, it shows you exactly what angle is directly across from it. That X that's formed, the ones that are on opposite sides of that X are vertical angles. And that tells you that they're actually the same measurement. If this one's 40 degrees, then I know that this is also going to be 40 degrees. So I know that FXD is the exact same thing as GXA. Those are the same angle. They're vertical to each other, which means that they're equal. They're across and they're equal. Complementary and supplementary, they could be vertical, they could be adjacent, they could be either one of these 2 really. But really, all we know is that they add up to 90 or 180. So it doesn't tell us so much about where they are, it tells us what they add up to. So, actually, let me erase that because I got a little bit sloppy. This angle, I'm going to start with that again. FXD is 40. Together, this angle and this angle form that right angle there. Those 2 angles, angle C, oops, that's supposed to be a C. C, XF, and FXD are complementary, which means that that has to be 50. They form a right angle together. That's what that box is showing. So if this is 40 and they add up to 90 altogether, you can do 90 minus 40. That tells you the leftover part, which is 50. Those are 2 complementary angles, and they also happen to be adjacent. They're right next to each other. They don't have to be. For example, this angle, those 2 are vertical. That's 50 degrees. So angle GXE and FXD, those are complementary, but they're not adjacent. They add up to 90, but they're not right next to each other, and they're not vertical. They just have the one word that can describe them, which is complementary. I'm going to use that same starting angle of fxd and look for something that is supplementary with it. And there's actually two in this picture. I'm going to extend this line. If they're going to add up to 180, they have to make a straight line together. So this angle, so let me get rid of that. This angle down here completes this straight line with this 40 degrees. That's 40. This has to be 140 because I know that this angle here, that straight angle, is 180 degrees. 180 minus 40 tells me this leftover part, which is GXD. These two angles are supplementary because they add up to a straight line or 180 degrees. And there's another one in here. I'm going to extend this line. That line going straight across. It's kind of the same thing, and actually we can see that because these are vertical. But this angle is a straight angle. When you outline it like that, forming the angle, you get a semicircle. That's 180 degrees altogether. That means those have to be supplementary. That means this angle, which is AXF, is also 140 degrees because together that angle and that angle have to add up to 180. So this just generally describes those relationships. And the word relationships there is really important because it's describing more than one angle. An adjacent pair of angles are next to each other, vertical or across from each other. They're talking about two angles. It's not talking about one angle that adds up to 90 degrees. That's a right angle. If I talk about one angle that adds up to 90, like this one, that's just a right angle. There's no reason to use the word complementary there. Complementary is referring to the two angles together, this one and this one, forming a right angle. If I want to talk about 180 degrees, I don't use the word supplementary unless I'm talking about two angles put together. This by itself is a straight angle. This angle here, that right angle, and that right angle put together, those are supplementary because it's talking about the relationship between them. It's talking about two angles that are put together to form that total of 180 degrees. Right, now we're going to use those words to actually talk about finding missing angles and sometimes even finding a value of x. So these pairs are both complementary. That's really the first thing that you want to think about. What do I know about those two angles? This angle and this angle. I know that they're complementary because they form that right angle. So they add to 90, which means 37 plus x, that plus that equals 90. That tells me that x, I'm going to subtract 37 on both sides. X is 53 degrees. This angle has to be 53 degrees because that plus that equals 90 degrees altogether. Now, the reason I set this up in this equation, you could probably shortcut this. You could probably just think about this as 90 minus 37, but you see that that's exactly what I'm doing for the math there. You could probably just jump right to this. But the reason I'm setting that up is because on this type of a problem where we have variables in there, it's going to become really handy to actually set up that equation. So I'm going to think about this and this together forming that same total. X plus 4 plus 3x plus 2 adds to 90. This equation is completely coming from their relationship. I know that they add up to 90 degrees altogether, so that's what I'm showing. That plus that adds up to 90. Now I'm going to solve that equation. I'm going to combine like terms. X plus 3x. That's really 1x plus 3x, but that becomes 4x. And 4 plus 2 becomes 6. That equals 90. Then I'm going to solve that by subtracting 6 from both sides. That gives me 4x equals 84. And then I divide by 4 as the last step. And x equals 21. So there's no instructions on this problem. So really, that could be the end of this problem. If it says solve for x, that might be your answer. If it says solve for a missing angle, like let's say I wanted to find this angle. Oops. If I wanted to find that missing angle, then I need to take that x value, this, and plug it in to that expression. 21 plus 4 would give me that angle is 25 degrees. If I wanted to find this one, I would do the same kind of thing. 3 times 21 plus 2, 3 times 21 is 63, plus 2 is 65. So all of this came from knowing that they add up to 90 degrees. That helps me find the value of x, and then plugging in that x value tells me what those angles are that actually add up to that 90 degrees. This number is the only number that works in these two expressions to make these add up to 90 degrees. That's really what we found here. The number that makes this expression and this expression add up to what it's supposed to, which is that 90-degree angle. Right, these two, I can see that those are making straight lines, so those are supplementary. Which means they add up to 180, and that's going to generate my entire equation. X plus 118 together, those form a straight line. That means they add up. Oops, that is a sloppy 8. I'm going to try that one again. They add up to 180 degrees. So I subtract 118 from both sides. It's pretty sloppy 8 also. But x is 62 in that case. 62 plus 118 would give me that straight line or semicircle, which has 180 degrees in it. The same relationship is true here. This forms a straight line. So this plus this, 70 plus 4 plus 2x. That plus that equals 180. I'm going to combine like terms again. That's 74 plus 2x equals 180, and then I'm going to solve this two-step equation. Minus 74 on both sides. That gives me that 2x equals 106. And then we divide by 2 and find out that x is 53. So that's my value of x. That makes this relationship true. That makes that add up to that straight line of 180 degrees. I could have probably found that a little bit easier, though. If this is 70, that means this has to be 110. That tells me that angle. So another equation that I could have set up is that 4 plus 2x equals 110. I think it's probably easier just to do this every time, just because then you don't have to, like, it's not as much problem solving as much as, I mean, either way you want to think about it is good. It's good math either way. But this is a systematic way to think about all of these supplementary angles. They always add up to 180. This is more of fluid problem solving. If you're up to that level, do that. If not, I would stick to that system of thinking. Either way, this would give you that x is 53. If you were to take that number and plug it in here, you'd find that that angle is 110. All right, and our last set is vertical angles. We don't have equations for adjacent angles because we don't know what adjacent angles really add up to or equal. We don't know anything about the numbers for for adjacent angles. We know that supplementary add up to 180, complementary add up to 90. That's where these equations are coming from. Those two add up to 90. These two add up to 180. Vertical angles are equal, or in geometry we say that they are congruent. Those are the same thing, which actually generates our whole equation. This equals that. We're going to put a big equal sign in between those, and that is the equation that we want to solve. 2x equals 74, and so x is, we're going to divide by 2 on both sides, x is 37. Excuse me. And that should make sense. When you take that number and plug it in there, 2 times that 37 tells us that that is 74, which is what it should be. That should be the same as the angle that's across from it. Just as a bonus, we know that this is 106, because that makes a straight line together. And these are across, so that's also 106. Same kind of thing here. We know that these two angles, they're on opposite sides of that X shape. This angle and this angle have to be the same. So 5x equals 2x plus 24. To solve this, this is not combining like terms. They're separated by an equal sign. So this is a little bit different than combining like terms. I'm going to subtract to move this 2x to the other side. Anytime they're separated by an equal sign, you have to cancel out this positive 2x by doing the opposite, by basically just subtracting it away, and do the same thing on the other side. That gives us 3x equals 24. That comes from that 5 minus 2. If it said this, if they're now on this side of the equal sign, then I'm combining like terms. They're both on the same side. That's adding. That's not what I have here. I have them separated by that equal sign, so I have to cancel this out and bring it to the other side. So my last step is that x is, I'm just dividing by 3, x is 8. So the x value that makes this equal to this is 8. That might be the end of your problem. If it's looking for the angle, then you have to take that and plug it in here or plug it in there. 5 times 8 is 40. And not surprisingly, this should give you the same exact thing. 2 times 8 plus 24, 2 times 8 is 16, plus 24 is also 40. So the angle is 40 degrees. The x value that makes those angles the same is that 8 degrees. Again, a little bonus, this is 140, because those make a straight line. Hopefully this helps you review for that second part of the test, but if you still need help, please email me with specific questions about things that you don't understand.